more so than most planets. It's about 20% larger at perihelion than it is at aphelion, or away from the sun, which is quite a bit. Then there's our own eccentricity to throw in and other details like that. So it turns out that actually its closest approach to Earth is not at perihelion, or, for that matter, at opposition. These are three different things, so let's run through them. Opposition is when Mars is on the opposite side of the Earth from the Sun. Then there's perigee, which is closest to us, the Earth, and that's a different thing. Since we're both traveling on eccentric paths, it turns out that the closest it actually gets will be on the 31st, not the 27th. And you will not be able to tell the difference. So, any time in there is fine. But it's not a starkly close opposition, because its perihelion is actually not until late September. I wrote that down here somewhere.
Excuse me, could you step closer to us? I'm having a hard time hearing you.
Actually, if I step closer, it won't make any difference whatsoever.
Because you're at perihelion.
Exactly. It's all coming through here.
Yeah, put the mic closer.
Here. Oh, you mean hold it closer.
Yeah. Yeah.
Does that work better? Okay. Okay. So this is about the biggest and brightest that you're going to see Mars since about 30 years ago, maybe 15. There's some argument about that, and it might continue right now. But this kind of thing happens roughly about every 15 years right now. Now, things that you will likely hear: that Mars will appear bigger in the sky than the moon, approximately like this. Some of the people who say this very cleverly say that Mars will be bigger than the moon. They are correct. Mars is bigger than the moon. But it's not going to look like that, and you might think that it would look more like this, right? No. No, this is great. This is what it would look like through a really good telescope. Actually, what it will look like is about like this. Got that? So, when you hear that one, forget it. You'll also hear that it will be brighter than the moon. It won't. So, forget that one too. There's usually somebody who says that it might hit the Earth. No. No. And we can pretty much expect that you won't be able to see Matt Damon up there if you take a look. Okay, so there's actually some news there. If you hadn't heard about the opposition, you probably haven't heard about the dust storm that's going on. Have you? Anybody? No? Okay, we got a global going. It first appeared May 30, I think. Let me see here. Yeah. It was first noticed by some amateur astronomers on May 30. That's usually what happens because nobody else bothers looking at Mars. And when that happens, you think, gee, isn't that strange? The answer is no. Dust storms at perihelion are extremely common. And going back to what you remember from Kepler, there's actually a pretty good reason to this. Not only when it's nearing perihelion is Mars getting warmer, stands to reason, right? So there's more energy in the system, but it's doing it really fast compared to the rest of its orbit. It's racing toward the sun, and that's creating a temperature differential. So you will inevitably see something about how great it is to observe Mars when it's near perihelion, and usually that's not true. Usually what happens is it gets covered with dust, like it is right now, and all you can see is a great big fuzzy red thing. And that's pretty much the way it's going to be. On June 20th, it went global, officially. These are fairly rare, but it's absolutely spectacular from the standpoint of science because no one knows why this happens. Little dust storm starts, it starts getting bigger, it starts getting bigger. The next thing you know, all of Mars is covered by a dust storm, completely gone. So, your first question is, what's going to happen to Opportunity, right? That poor little rover that's been up there chugging away for 14 years, and all this dust comes along, and its solar panels go dark, and it just dies out, right? JPL, our buddies at JPL, do not think this is going to be any kind of issue. There have been worse dust storms that it's been through. It just goes into a safe mode, sits there for a while until the sun comes back up through the clouds. So that really shouldn't be an issue. And the other rover, of course, is nuclear powered. So it has no problem, and it's just chugging right along. Signals are a little weird, and it's not getting much in the way of pictures, but everything should be fine in that regard. So what does it mean if you want to take a look at Mars? If you break out your telescope, what you're probably going to see is not much different from an orange ball, except usually, even when there's a great big dust storm, you can still see the poles. Well, so there's a little white dot at the bottom and top. And that's about it. That's all you're going to see. And, oh, bad news, right? Well, not necessarily. There's an advantage to this. It's going to be a great big orange ball, comparatively speaking. You know. But that means that the albedo goes up a little bit. It's going to be throwing a little bit more light. If you bothered to look at it in May, it was probably about -5 magnitude, which is, you know, fairly bright as stars go, but they were projecting a 2.7.